By definition, inverse relation means interchanging the first and second coordinates of a set of ordered pairs. This will create an inverse relation. So in general, if I'm being asked to either graph or find the equation of an inverse, then I want to find the ordered pairs for what I would call the original equation and then switch them. This example asks us to consider the original equation y equals x squared plus 1, and then it specifies to use the values x equals -2, -1, 0, 1, and 2 to create 5 ordered pairs for the original relation. Let's go ahead and do that. So plugging -2 into my x squared plus 1, I would get -2 squared plus 1. -2 squared is 4. 4 plus 1 would give me 5. So the ordered pair here would be -2, 5. Plugging in -1, I'd have -1 squared plus 1. 1 plus 1 is 2. So the ordered pair would be -1, 2. Plugging in 0, I would have 0 squared plus 1, which equals 1. So that ordered pair would be 0, 1. Plugging in 1, I'd have 1 squared plus 1, which is 1 plus 1, which is 2. So the ordered pair is 1, 2. And then finally plugging in 2, 2 squared plus 1 is 4 plus 1, which equals 5. And so the ordered pair there would be 2, 5. To find the inverse relation, I would take each of these 5 ordered pairs and I would invert them, meaning I put the y coordinate first as the new x coordinate, and then the x coordinate second as the new y coordinate. So just reverse the order of your x and y to find the ordered pairs for the inverse. So it would be 5, -2, 2, -1, 1, 0, 2, 1, and 5, 2. Okay, now the instructions here says to create the inverse relation using the coordinates, so that's what we've done here, and then graph the 2 results, the original and the inverse. I'm going to do this color-coded. I'll do the original in blue, I'll do the inverse in red. So coming down below, in blue, -2 and 5, -1 and 2, 0 and 1, 1 and 2, and 2 and 5. So we can see that the original function, and we know this already, is a parabola. Okay, now I'm going to go in red and sketch the inverse relation. So we have 5, -2. We have 2, -1. We have 1, 0. We have 2 and 1. And then we have 5 and 2. So this looks kind of like a parabola, but it's laying on its side. It actually is not a parabola, meaning that it's not a squared kind of function, but it has the same shape. Okay, now there's something that I'd like you to notice, and that is that the 2 functions are reflections of themselves over the line y equals x. The line y equals x bisects the first quadrant, meaning it's cutting through at a 45-degree angle. So this is the line y equals x. I'm using a dotted line here because it's not actually a part of my graph of these 2 relations, but I'm using it as a reference point. Notice if I imagined trying to fold, let's say, my red graph over the y equals x line, then the 2 graphs would exactly match up. In your notes, if you look at the bottom of the page, there's a note about the line y equals x. And here, what you should write in, the inverse relation is the mirror image of the original over the line y equals x. That is, if you fold the graph of the original over the line y equals x, the result would be the inverse. So we can go back up and we can fold either the blue graph over the y equals x line. If we did that, it would match up with the red, or vice versa. Fold the red over the y equals x line and it would match up with the blue. Okay, we have then been asked below to find the domain of the original. So look at the blue graph. The domain of that would be negative infinity to infinity because it goes infinitely in both directions in the x direction. So this would be negative infinity to infinity. The range of the original. So the range are y values. We notice that our smallest y value is 1. It is included, so it would be 1, and then it goes infinitely up, so it would be 1 to infinity. Now look at the domain of the inverse. The domain of the inverse are your x values. Notice that the smallest x that you have is 1. It is included, so we would use a bracket, and then it goes infinitely to the right, so bracket 1 to infinity. The range of the inverse are the y values. Well, the graph understandably goes all the way to infinity up, all the way to infinity down, and so here, negative infinity to infinity. Okay. Notice here in your notes, there's a note about domains and ranges. Basically, they are reversed in the inverse relation. So notice that if we're talking specifically about the inverse, if we know the domain and range of the original, then we basically just switch them. So in other words, the range of the original becomes the domain of the inverse, and the domain of the original becomes the range of the inverse. This should make sense because by definition, finding an inverse means switching x and y. So if we think about domain being x in the original, then the domain would become y in the inverse, or the range, and vice versa.